Welcome pre-cal students to the homework help video, page 580, numbers 1 through 27 odd, and numbers 49 through 99 odd. Please notice also that you only need to do the A's. Every time that a problem has an A or a B, you only have to do the A. So please make note of that, and let's go ahead and get started. Numbers 1 and 3, the directions say to determine the exact values of the 6 trig functions of each angle. So notice first of all we have our angle drawn right here for us, and notice that the ordered pair right here is over 4 and it's up 3. So basically what we have is a right triangle right here. Looks like this. And it's not a very good right triangle. Let's try that again. Looks like this. Theta's right here. As you can see right here, we're over 4 and we're up 3. Okay, so we're going to find the 6 trig functions. Don't forget in quadrant number 1, all of the signs are positive, 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 and so here we go. If you use Pythagorean's theorem, you will find this side to be 5, and here we go. The sine of theta equals opposite over hypotenuse 3/5, so the cosecant of theta would be the reciprocal 5/3. The cosine, sorry students, I'm going pretty fast here, a little sloppy. The cosine of theta would be adjacent over hypotenuse, and the reciprocal function for cosine is secant, and so the secant of theta would be 5/4. The tangent of theta would be opposite over adjacent, so 3/4. So the reciprocal function cotangent would be 4/3. And just that quickly, we're moving on. Number 3. Okay, students, notice that we have a right triangle right here that goes like this. Okay, and then down. Now, do you understand the angle that we're trying to find, the sine, cosine, tangent, cosecant, secant, cotangent is this angle that goes from here all the way to here. But remember, we've learned that this angle right here, you can also use the reference angle, which would be this angle right here, as long as you remember that sine is, let's see, what are the sine sequences here? Sine is negative, cosine is negative, and tangent is positive. So please don't forget those signs, okay? So here's our triangle. Let's go ahead and draw the triangle over here so we have a little better picture of it. All right, and theta is right here. And then here we go. Let's see, it's over square root of 3. We know that from right here, and it's down 1. Now you could put the negative sign here and the negative sign here, but there's no need to do that. If you use Pythagorean's theorem, I believe you'll get 2. I did that in my head. Let's see, square this, you'll get 3. Square this, you'll get 1, 4. Yes, you'll get 2. And so with that in mind, let's go ahead and find the 6 trig functions of theta. And don't forget your signs over here. It's very important, okay? So the sine of theta is negative, so we'll put a negative sign here. And it would be opposite over hypotenuse, so 1/2. So the reciprocal function cosecant of theta would be -2/1, or -2. The cosine of theta, please notice it is also negative, so it'll be negative, and it would be adjacent over hypotenuse, so square root of 3/2. And then the reciprocal function secant would be 2 over square root of 3, so 2 over square root of 3. However, if you rationalize that, you will get 2 square root of 3/3. And you do need to rationalize, okay, students? It's pretty standard for higher level math. Okay, tangent of theta, opposite over adjacent, so 1 over square root of 3, and tangent is positive, so it'll be positive. So we have 1 over square root of 3. Now I'm going to rationalize that in just a second. Before I do, though, let me go ahead and write my cotangent. If you flip 1 over square root of 3, you get square root of 3/1, which is square root of 3. All right, and now let's come back over here to this one. 1 over square root of 3 would be square root of 3/3 after you rationalize it, okay? All right, moving on to number 5. The directions for 5, 7, and 9 say the point is on the terminal side of an angle. Determine the exact values of the 6 trig functions. So we can do this pretty simple and pretty quickly. Wow, that's a really nice straight line, isn't it? Let's try that again. Let's go like this, and let's go like this, and here we go. Okay, so we're going to go over 7 and up 24, so the point will be up here somewhere, and we'll go ahead and sketch our, there we go, our line. And so we're looking to find the 6 trig function values of this angle right here. Okay, we'll call this theta. Well, we know that we're over 7, and we know that we're up 24. All right, so this ordered pair right here is 7, 24. We also know that in quadrant 1, all of the trig functions are positive, positive, positive. Okay, so here we go. Quickly using Pythagorean's theorem, let me grab my calculator real quick here. We're going to square one leg, 24 squared, plus we're going to square the other leg, 7 squared, and you get 625, and take the square root of that and you get 25. So students, you are pre-cal students, so I'm not going to do that math for you. You should know how to use Pythagorean's theorem by now, and so if you do Pythagorean's theorem correctly, the hypotenuse is 25. Okay, so here we go. The sine of theta would be opposite over hypotenuse, 24 over 25, so the reciprocal function cosecant of theta would be 25 over 24. All right, now cosine. Cosine of theta would be adjacent over hypotenuse, so 7 over 25, and the reciprocal function for cosine is secant, so the secant of theta would be 25 over 7. And of course, tangent of theta is opposite over adjacent, so 24 over 7, and so then the cotangent would be the reciprocal of that, which is 7 over 24. Hope that makes sense. Moving on to number 7. All right, now number 7 is -4, positive 10. So if we go over 4 and up 10, we know that we're in quadrant 2 right here. That's obvious, students. We're going over 4 and up 10. So we go over 4, up about 10, and be about right here, just kind of estimating that. And we'll just kind of do a little sketch line here and come down like this. And theta is from here to here. There's theta. But remember, students, you can find the sine, cosine, and tangent of the reference angle of theta as long as you remember the signs for your 6 trig functions are positive, negative, negative in quadrant 2. So even though we're trying to find the 6 trig functions of this angle right here, we'll call this theta subscript 1. We can use this right here to help us, okay? And so here we go. Let me get a drink here real quick. And let's continue on. Here we go. So the sine of theta, oh, I better fill the numbers in. Sorry about that. Let's see. You go over 4 and up 10. So Pythagorean's theorem would be, let's see, 100 plus 16, 116. So the square root of 116. Now, probably in the back of the book, I'm assuming they would want you to simplify that. And I'm not sure if you can. Let's see if you can. Yes, you can. Okay, I'm going to go ahead and simplify the square root. If you didn't do that, I'm okay with that. But really, as you get into upper level math, you should realize the square root of 116 is the same thing as the square root of 4 times 29. And the reason we split up 16 into these two factors right here is 4 is a perfect square. So we know the square root of 4 is 2. So we cross off the 4 and we put a 2 on the outside. So the square root of 116 is the same thing as 2 square root of 29. Now again, if you use the square root of 116, I'm okay with that. But this is more appropriate, okay? So sine of theta would be opposite over hypotenuse. So 10 over 2 square root of 9. Now, or square root of 29. Now I've got to rationalize that. Before I do though, I'm going to go ahead and write the reciprocal. The cosecant of theta would be 2 square root of 29 over 10. Now let's go ahead and take this right here and let's rationalize this. I'm going to go ahead and do this for you because it is a little more difficult. We're going to multiply the top and the bottom by the square root of 29. And if we do that correctly, we'll get 10 square root of 29. Let's see. I have this feeling I made a mistake up here. Let's see, over 4 and up 10, 169. It looks right. Okay. 10 times the square root of 29 is 10 square root of 29. There's a 1 right here on the outside, so 2 times 1 is 2. And the square root of 29 times the square root of 29 is just 29. So you're going to end up taking 2 times 29, which is 58. Okay. Now you can reduce outside numbers. So 2 goes into both of these numbers. 2 goes into 10 5 times, and 2 goes into 10 29 times. So you end up with 5 square root of 29 all over 29. That's a lot of work, and that's why I wanted to do that for you, okay? All right, moving on to the cosine of theta. Cosine of theta would be adjacent over the hypotenuse. Now, I know that I have to rationalize this, but I'm first going to write the reciprocal function over here, which would be 2 square root of 29 all over 4. Now let's go ahead and rationalize this. We're going to multiply the top and the bottom by the square root of 29, square root of 29. So we have 4 square root of 29. There's a 1 right here, so 2 times 1 is 2. And square root of 29 times the square root of 29 is just 29. So 2 times 29, sorry about that, 2 times 29 would be 58. And you can definitely reduce 4 over 58. 4 goes into 4, or 2 goes into 4 twice, and 2 goes into 58 29 times. So we end up with 2 square root of 29 all over 29. All right. And moving on now, if I can get my eraser to work here, there we go. And tangent should be a lot easier. For tangent, there's not going to be any square root, so tangent would be opposite over adjacent, so 10 over 4 was reduces to 5 halves, and so the cotangent, the reciprocal function, would be 2/5. Okay, moving on to number 9. Hopefully this one will not be as difficult, but seeing that we have a fraction right here, I don't think it's going to be very pretty. I think it's going to be pretty ugly, but oh well, so be it. So here we go. We're going to go over negative 5/12 then up 1. I'm not going to try to draw my my triangle to scale because negative 5/12 would be barely over to here, and then 1 would be barely be up to here. So I'm just going to draw it pretty big. I'm going to go over, well, we're going to go over and then up to about right here. All right. And we're going to call this ordered pair negative 5/12, negative 5/12, comma 1. So let's draw this down like this, and let's go over like this. So here's your theta, but we're going to use this theta here as long as we remember that the signs here for your 6 trig values are positive, negative, negative. And so with that in mind, let's go ahead and label our sides. So we know this side here is 5/12, and we know this side here is 1. So this will be interesting. We're going to square the 1, and we're going to square the 5/12. So see what we get here. Equals hypotenuse squared. Square the 1, that's a 1. Square the 5/12, so you get 25 over 144 equals 8 squared. If you add those together, you will get, and learn to use your calculators here, students. Learn to take 1 plus 25 divided by 144, enter, and then hit math, enter, enter. If you do that correctly, you're going to get 169 over 144, okay? And now take the square root of both sides. The square root of 169 is 13, and the square root of 144 is 12, and that equals h. Okay, so your hypotenuse is 13 over 12. I'm so glad we have no radicals, no square roots. That would have been really, really difficult, and I probably would have retired from teaching. Okay, so here we go. Let's take a look here at sine. Okay, sine of theta would be opposite over hypotenuse, so 1 over 13/12. And students, I'm going to work this out for you one time. Did I remember my signs back here? I did not. I'm so sorry, guys. Let's go back to number 7. I'm very sorry. Cosine will be negative, secant will be negative, tangent will be negative, and cotangent will be negative. I apologize because your sine sequence is plus, minus, minus. Sorry, students. Okay, moving on to number 9. Now, I'm only going to do this for you a couple of times. 1 over 13 over 12 means 1 divided by 13/12. And you know 1 is the same thing as 1 over 1. Division when you're dealing with fractions means multiply as long as you flip the second fraction, so 12/13s, and 1 times 12 is 12, and 1 times 13 is 13. Okay, so you would get 12/13s, and just want to make sure you see that. Okay, so let's go ahead and do that. There we go, and here we go. So opposite over hypotenuse, 1 over 13/12 would be 12/13s, and then of course the reciprocal, cosecant theta would be 13 over 12. Both of those are positive. Now cosine of theta would be adjacent over hypotenuse, so you would have 5/12 over 13/12. Okay, students, got it? So really that's 5/12 divided by 13/12, or 5/12 times 12/13. All right, and your 12s would cancel, and you're left with 5/13. So the cosine of theta will be 5/13, negative, of course, because of this negative sign right here, and the reciprocal function is secant, so secant of theta will be negative 13/5. Okay, and let's continue on, students. Here we go. All right, taking a look at tangent. Tangent of theta, oops, that should be an n. Tangent of theta would be opposite over adjacent, so 1 over 5/12, and of course 1 divided by 5/12 would be 12/5. You can work that out on your own later if you have time. So 12/5, which would be negative, of course, because of this negative sign right here. And so the tangent of theta is negative 12/5, and the cotangent of theta, the reciprocal function for tangent, would be negative 5/12. Okay, hope that helps. Moving on to number 11. Okay, for numbers 11 and 13, they want us to state the quadrant in which theta lies. Now, this is really simple. Let's go really fast here. The sign sequence here is positive, positive, positive. Over here it's positive, negative, negative. Here it's negative, negative, positive. And then over here it's negative, positive, negative. Now, okay, first of all, the first clue they give us is sine of theta is less than 0. In other words, when you take the sine of theta, it'll be less than 0, so the sine of theta is a negative number. Less than 0 means negative number, so the sine of theta is a negative number. So which quadrant is sine negative in? Well, sine is negative in quadrant 3, and sine is negative in quadrant 4. So we've narrowed it down to 2. Cross this off, cross this off. Now, they tell us that cosine of theta is also less than 0, so cosine is also negative. Well, cosine here is positive, so it can't be this quadrant. Here, cosine is negative, so there we go. Quadrant 3. Quadrant 3 satisfies both of these requirements, or both of these constraints. Okay, number 13. All right, let's go ahead and put our quadrants back up here. Plus, 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 minus, 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 plus, and then minus, plus, minus. Now, our first constraint is sine of theta is greater than 0. So we're looking for where sine is positive, greater than 0. That would be this quadrant here. Sine is positive, and this quadrant here. Sine is positive. Okay, and then we're looking for the quadrant where tangent is negative. Tangent is less than 0. Well, tangent is not negative here, but tangent is negative here. So this would be quadrant 2. Okay. Moving on to numbers 15 through 23. Odd. Find the values of the 6 trig functions. So here we go, going pretty quick. First of all, we understand we're in quadrant 2. So here we go. Here's theta. Or here's the arrow. You can say theta and call this theta also, whatever. And sine of theta is opposite, which is 3. Remember, let me back up here. When you take the sine of theta, the fraction you get out is opposite over hypotenuse, okay? So 3 is your opposite side, hypotenuse, 5 is your hypotenuse. And remember, whenever you draw your triangles in a quadrant, you always put theta right here, and you always draw your triangle onto the x-axis. It's like this, students. Look at it like it's a bow tie. Like that. If you remember it should look like a bow tie, then you'll always know how to draw each triangle in each quadrant. Okay, so with that in mind, here we go. So the opposite side of theta is 3, the hypotenuse is 5. If you use Pythagorean's theorem, you'll get a 4 here, and the sign sequence are positive, negative, negative. So I think we're cruising big time on number 15. So we'll slide this over here, and here we go. The sine of theta is opposite over hypotenuse, and the reciprocal function cosecant of theta would be 5/3. It'll be positive because of this. The cosine of theta will be adjacent over hypotenuse 4/5, and it will be negative because of this right here. The reciprocal function secant of theta will be negative 5/4. Tangent of theta will be negative because of this sign right here. Tangent is opposite over adjacent, so 3/4, and so the reciprocal function would be negative 4/3. Negative 4/3. Cruising on to number 17. Okay, we are told that tangent is negative. So let's see, what quadrant would that be? Where is tangent negative? Tangent is negative here. And tangent, I'll put check mark, tangent's negative here, and tangent's negative here. However, they also tell us that sine also has to be negative, and sine is not negative in quadrant 2. It is not. So the quadrant we're dealing with is this quadrant here. So I'm going to go ahead and draw my triangle. And remember the bow tie. Okay, that's how you know how to draw your triangle. Remember the bow tie. Okay, so this is our theta right here. And here we go. Let's see, tangent of theta would be opposite over adjacent. So here's theta. Opposite would be 15. Adjacent would be 8. And now let's quickly find 8 squared plus 15 squared would be 289, and we'll take the square root of that and we will get 17. So we have 17 for the hypotenuse, and here we go. The sine sequence over here is negative, positive, negative. So sine of theta would be negative, and it would be 15 over 17, opposite over hypotenuse. And so the reciprocal function cosecant of theta would be negative 17 over 15. Okay, it's negative because of this. Now cosine will be positive, so cosine of theta will be positive, adjacent over hypotenuse, 817, and so the reciprocal function secant will be 17 over 8, and then tangent of theta will be negative because of this, so a negative here, and tangent of theta would be opposite over adjacent, so 15 over 8. And so the reciprocal function, cotangent, reciprocal of tangent, cotangent would be negative 8 15ths. Okay, hope that helps. Moving on to number 19. Okay, on number 19, let's see, we're looking at cotangent is negative. Cotangent of theta is negative. So where would cotangent be negative? Well, cotangent is negative here, and cotangent is negative here. Remember the sine sequence is positive, negative, negative. And over here it's negative, positive, negative. So right here, so tangent is negative. And then they also tell us that cosine is positive. Cosine of theta is positive. So we're dealing with theta. Cotangent of theta is negative. Cosine of theta is positive. Well, cosine here is negative. Remember the sine sequence is positive, negative, negative. So we're definitely not dealing with the second quadrant, so we're dealing with the fourth quadrant. So here we go. Draw our triangle, put theta right here, and here we go. Cotangent of theta is negative 3 over 1. Now if tangent is opposite over adjacent, then cotangent is adjacent over opposite. So here's my theta, and the adjacent side would be 3 and the opposite side would be 1, and so the hypotenuse, if you use Pythagorean's theorem, would be square root of 10. Okay, students, I'm back. Let's see now. The sine sequence here is negative, positive, negative. So sine is going to be negative. Sine of theta would be opposite over hypotenuse, so negative 1 over square root of 10. Now we're going to rationalize that in just a second, but let's go and use this to get the reciprocal function. Cosecant of theta would be negative square root of 10 over 1, or negative square root of 10. Now if we rationalize this right here, we're going to get negative square root of 10 over 10. Alright, now let's go on to cosine. Cosine of theta is positive because of this sign right here, positive, and so cosine of theta would be adjacent over hypotenuse, so 3 over square root of 10. And before we rationalize that, let's come over here and get the reciprocal function. Secant of theta would be square root of 10 over 3. And now if we rationalize this, we will get 3 square root of 10 over 10. Alright, tangent of theta will be negative because of this sign right here, and opposite over adjacent would be 1/3, and then cotangent would be negative 3 over 1, or negative 3. Alright, moving on to number 21. Excuse me. Alright, here we go. Oh, secant is negative 2, and of course secant is the reciprocal function for cosine. So where is cosine negative? Cosine is negative here because it goes positive, negative, negative, and cosine is negative here, negative, negative, positive. Alright, but we're also looking for the quadrant where sine is greater than 0, or sine is positive, which would be this quadrant right here. So we will be dealing with the top quadrant, the second quadrant. So here's my triangle. Don't forget, you know how to draw that because of the bow tie. That's how you know that. Don't forget that. And so theta goes right here, and the sign sequence is positive, negative, negative. All right. So now think about this, students. If cosine is adjacent over hypotenuse, then secant is hypotenuse over adjacent. So your hypotenuse is 2 and your adjacent side is 1. If you use Pythagorean's theorem, you will get square root of 3. Okay, you will get square root of 3. I think I did that in my head. Let's see, 4 minus 1, yes, square root of 3. And so here we go. Sine of theta is positive, and it would be opposite over hypotenuse, so square root of 3 over 2. And the reciprocal function cosecant of theta would be 2 over square root of 3. And if you rationalize that, you will get 2 square root of 3 over 3. Okay? And now let's go on to cosine. Cosine is negative, so we'll put negative. Adjacent over hypotenuse, so 1/2. And so the reciprocal of cosine is secant. Secant of theta is negative 2 over 1, or negative 2, which we already knew that up here. Okay, tangent of theta is, first of all, going to be negative because of the negative sign here. And then tangent will be opposite over adjacent, so square root of 3 over 1, which is square root of 3. And of course, if you flip that for the inverse cotangent, you will get 1 over square root of 3, negative 1 over square root of 3, like this. If you flip this, you'll get this. But then we have to rationalize this fraction over here to the right, so we would get square root of 3 over 3. Okay? Now moving on to number 23. Okay, this will be interesting. Cotangent is undefined. And let's go ahead and draw our coordinate plane here. It says theta is greater than pi over 2. And notice this, students, it's real important you see this. It also says equal to. So theta is greater than pi over 2 and equal to it. And theta is less than 3 pi over 2, which is down here, and also equal to it. So theta can be anywhere from here all the way to here. Now, students, think about this. The only time, we should know this by now, the only time that a trig function value is going to be undefined is if you're dealing with a quadrant angle. And the only quadrant angles I know of that go from here to here would be this one, which is 90, this one, which is 180 or pi, and this one, which is 270 or 3 pi over 2. Okay, so I'm going to grab my handy dandy calculator and I want to talk to you guys for a second. Please listen to me, students. Please listen to me. If cotangent is undefined, then that means tangent of theta is what? Do you remember we talked about this? The reciprocal of 0 is undefined, and the reciprocal of undefined is 0. So I'm going to take my calculator, I'm going to type in the tangent of 90 and see if I get 0. Nope, I did not. Now I'm going to type in tangent of 180 and see if I get 0. Yep, so far so good. Now I'm going to type in the tangent of 270. Nope, I did not get 0. So going from here to here, the only angle that's going to satisfy theta is 180 degrees. So I'm trying to find the sine of 180, the cosine of 180, and the tangent of 180. And of course, also they're reciprocal. So sine of 180 is 0, and so the reciprocal function cosecant would be u for undefined, un for undefined. Okay, the cosine of 180 is going to be -1, and so the reciprocal of -1, secant of theta, would also be -1. If you flip -1, you get -1. The tangent of 180 should be 0. We've already tried that. We should get 0, and we do. And so the cotangent, I'm not sure why I put theta, old age I guess, there we go. The cotangent of theta would be undefined. And there we go. We did it. Very good. Moving on. Let's take a look at numbers 25 and 27. The directions say to the terminal side of theta lies on the given line in the specified quadrant. Find the values of the 6 trig functions of theta. Okay, not too bad. Here we go. Okay, let's start off with number 25 here. First of all, we're going to draw our coordinate plane over here. And then we're going to realize that we're in quadrant 2, okay? And we're dealing with y equals negative x. So you can pick out any numbers you want. I'm just going to put in 1 for x. And if I put a 1 in for x, I will get a negative 1 for y. Does everybody see that? Let's do it down here. Y equals negative x. If I put a 1 in for x, like this, then y equals negative 1. So the ordered pair that falls on this line, because the directions do say that the terminal side of theta lies on the given line. So I can draw a line like this, and it says that the terminal side is this side right here. Okay, so, and you say, well, Mr. Earhart, should you put in 1? Should you put in 2? Should you put in 3? Should you put in 4? You could put in any number you want, and in the end, you'll get out the exact same answers. Trust me, okay? Totally and completely. So with that in mind, I put 1 in for x. I got out negative 1, so we're going to go, that's not possible though. Hold on one second here, students. I apologize to you. I made a mistake here, and that happens quite regularly. If we're in quadrant 2, that means we're over here. And I apologize for not catching that. We're in quadrant 2. So if we're in quadrant 2, then we should put a negative value for x in. Doesn't that make sense? I mean, think about it. If we're in quadrant 2, we have to go over this way and then up. And so we're definitely going to have to use a negative number for x. Okay, so I'm going to use negative 1 for x. So y equals negative x. Y equals negative, then put a negative 1 in for x. And you get a positive 1 for y. So your ordered pair would be negative 1, positive 1. Okay, so we're going to go over and up. We'll put it right there. Draw our triangle. And we're over 1, and we're up 1. Okay, so there we go. All right, let's go over that again. First of all, students, I realize what quadrant I'm in, and then based on what quadrant I'm in, I then know if I want to put in a negative x value or a positive x value. And you might say, well, Mr. Earhart, how did you know to use 1? Students, you could have used negative 1, negative 2, negative 3, and negative 4. You would have got the same answers in the end, trust me, okay? But the smaller number you do, then the less reducing you have to do later when you're over here with your fractions. Like sine of theta is a fraction. You're going to be able to do a lot less reducing if you start off with smaller numbers over here. Okay, so I'm not going to put this negative sign here. So we're over 1 and we're up 1. So square root of 1 is 1. Square root of 1 was 2. Square root of 2. So the hypotenuse is square root of 2, and here's theta. Okay, so we're good. Let's fly. Okay, here we go. Let me slide my calculator out of the way here, and here we go. Sine of theta is up. First of all, the signs are positive, negative, negative. Sine would be positive 1 over square root of 2. So before we rationalize that, cosecant of theta would be square root of 2 over 1, which is square root of 2. And over here, we'll get square root of 2 over 2. Cosine of theta would be adjacent over hypotenuse, so 1 over square root of 2, which would also be the same thing for secant. We're going to invert that, or reciprocate. That would be a negative, sorry, because cosine is negative. So we have a negative sign here. We'd have a negative square root of 2. And over here, we'd have negative square root of 2 over 2. And then tangent of theta would be negative because of the negative sign here. Tangent is 1 over 1, which is 1. And if you reciprocate 1, you will still get negative 1. Okay. So there we go with number 25. Moving on now to number 27. Now in 27, notice we're in quadrant 3, students. So please don't miss that. We're in quadrant 3. So because we're in quadrant 3, 1, 2, 3, we're down here in this quadrant right here. Okay, because of that, we know we're going to go this way and then down. So we know that our x value has to be negative. Okay, so whatever I put in for x is going to be negative. Now you can put in negative 1 million, negative 1/2. I'm going to put a negative 1 in. So 2, negative 1, minus y equals 0. This is kind of easy. Just bring the negative y over and make it positive. So you have y, and then 2 times negative 1 is negative 2. So when you put a negative 1 in, you got out a negative 2. So your ordered pair is negative 1 comma negative 2. So that's pretty easy. Negative 1, negative 2. We'll put it right there. That's good enough. And this ordered pair is negative 1, negative 2. Let's go ahead and erase all of this here. Let's draw our triangle. Don't forget you have the bow tie thing to help you remember how to draw the triangle. So the triangle will look like this. And theta always goes here in the corner. Always. And so here we go. We're over 1. We're down 2. So the hypotenuse will be the square root of 5. And the sine sequence is negative, negative, positive. So here we go. Pretty simple. Sine of theta would be opposite over hypotenuse, so 2 over square root of 5. So secant would be negative, by the way. Sorry about that. So the secant, cosecant of theta would be negative square root of 5 over 2. If we rationalize this, we'll get negative 2 square root of 5 over 5. Okay. Cosine of theta would be adjacent over hypotenuse. It would also be negative because of your second sine, so negative 1 over square root of 5. And so the secant of theta would be the reciprocal of that, which would be negative square root of 5 over 1. Over here, let's rationalize. You will get negative square root of 5 over 5. The tangent of theta would be opposite over adjacent, 2 over 1, which is 2, and it will be positive because of this positive sign here. The cotangent of theta would be 2 flip, 2 over 1 flip would be 1/2, so 1/2. Okay. All right. Moving on to number 49. Number 49. Evaluate the sine, cosine, and tangent without using a calculator. Cool. I love it. Here we go. Now I think if you'll give your old teacher a second here, I thought we had, yeah, we didn't need this here, did we? Let's go ahead and copy this. We're going to use it now, that's for sure. There we go. And let's go whipping through this here, 29. And here we go. And we'll just shrink this for right now. All right, here we go. Okay, we're not going to do, we're going to start with 49. 49, 225 degrees. So we're going to rotate 180. And notice in the directions, students, it says evaluate without using a calculator. Okay, so we're not going to use a calculator. And so we're going to go from here to here, which is 180 plus 45 more degrees. And so here's theta. Theta goes from here, students, all the way to here. So we're trying to find the sine, cosine, and tangent of 225 degrees. Do you understand that? Okay, in fact, I'm not sure why I put theta. I'm going to go ahead and put 225 degrees. But remember what you learned yesterday. If you're trying to find the sine, cosine, and tangent of 225, that's the exact same thing as taking the sine, cosine, and tangent of the reference angle, as long as you remember to check your sines. Now, the reference angle right here would be 45 degrees, would it not be? I mean, 180 plus 45 more is 225, and the sine sequence over here is negative, negative, positive. And so it's okay to take the sine of 45 instead of 225, as long as you remember the sine of 45 is what? Negative. And now let's pull this up, and let's use our handy dandy table here. Let's see, the sine of 45 degrees would be square root of 2 over 2, so negative square root of 2 over 2. The cosine of 45 degrees is going to be negative, so we're going to put a negative sign here. And the cosine of 45 degrees would be square root of 2 over 2, same thing. And then the tangent of 45 degrees is going to be positive, okay? And the tangent of 45 degrees will be 1. So there we go. Not too bad. So the sine, I'm going to go ahead and change this now. The sine of 225 is negative square root of 2 over 2. The cosine of 225 is negative square root of 2 over 2. And the tangent of 225 is positive 1. Okay? Hope that made sense. Let's practice some more of these. Here we go. Let's take a look now at number 51, 750 degrees. Okay? Well, let's see. If we go around once, that's 360. Go around again, that's 720. So 30 more degrees. Okay, so there we go. So it's okay, students, to use 30 degrees instead of 750 as long as you realize the signs are positive, positive, positive. Okay, and so with that in mind, here we go. We're going to find the sine of 750, okay, which is the same thing as the sine of 30. And so let's pull this back up here. The sine of 30 would be 1/2. So the sine of 750 is the same thing as the sine of 30, which is 1/2, and sine is positive. The cosine of 750 is the same thing as the cosine of 30. And so cosine of 30 is square root of 3 over 2. I think it's really hard to read there. Let's go ahead and see if we can expand this a little bit. Yeah, square root of 3 over 2, and it will be positive because notice we are in the first quadrant. And then the tangent of 750 is the same thing as the tangent of 30, and so tangent of 30 would be square root of 3 over 3. And students, we are moving on, okay? Not too bad. Not too bad at all. Did not mean to do that, that's for sure. Alright, here we go. And let's see what we have here, okay? Alright, negative 150. Well, negative 150, let's pull this up here. Negative 150 means we'll go this way, and we'll go 90 plus 60 more. Okay, so there we go. So students, please think about that. If I just went 90 plus 60 more, that's 150. Notice the negative 150 means I'm going this direction. So 90 plus 60 is 150. So this little angle left over here on the inside has to be 30. So the reference angle for negative 150 is 30. It's not negative 30, it's just 30. So if I'm going to find the sine, cosine, and tangent of negative 150, that's the exact same thing as finding the sine, cosine, and tangent of 30, as long as I remember the sine sequence over here is negative, negative, positive. Okay? And so here we go. The sine of 150 degrees, negative 150 degrees, the sine of negative 150 degrees is the same thing as the sine of 30, as long as you remember it's negative, so negative, and that'd be 1/2, okay? 1/2. The cosine of negative 150 degrees would be the same thing as the cosine of 30, as long as you remember it's negative, so we'll put a negative sign here, and the cosine of 30 is square root of 3 over 2, and then the tangent of negative 150 would be the same thing as the tangent of 30, as long as you remember it's positive. Josh? Okay, students, sorry, I'm back. So the tangent of negative 150 is the same thing as the tangent of 30, as long as you realize that it's positive. So the tangent of 30 is square root of 3 over 3. And we are moving on to number 55. All right, number 55. All right, here we go. Number 55, 4 pi over 3. Now, students, don't forget that 4 pi over 3 is the same thing as 1 and 1/3 pi. Okay, so we're going to rotate 1 whole pi and then 1/3 more. So if we rotated 1 whole pi and then 1/3 more, then what's left over inside here is going to be pi over 3. Okay, so there's our reference angle. So as long as you remember, students, the sine sequence here is negative, negative, positive. You are more than welcome to use pi over 3 instead of 4 pi over 3, as long as you remember the sine sequences. Okay, let's grab this and drag it, gives a little more room over here, and here we go. So students, here we go. The sine of 4 pi over 3 is the same thing as the sine of pi over 3, as long as you remember the sine is negative. So the sine of pi over 3 is square root of 3 over 2, so negative square root of 3 over 2. The cosine of 4 pi over 3 is the same thing as pi over 3, as long as you remember that cosine is negative in quadrant number 3. And so the cosine of pi over 3 is 1/2. And then the tangent of 4 pi over 3 is the same thing as the tangent of pi over 3, as long as you remember it's positive. And so the tangent of pi over 3 would be square root of 3. Okay? And there we go. If you, by the way, students, if you wanted to take 4 pi over 3 and change that to degrees, you would get 240 degrees. And so you would rotate 180 plus 60 more. So instead of using pi over 3 inside of your triangle here, you would use 60. Well, look, that's the same thing we have right here. I mean, pi over 3 is the same thing as 60 degrees. So either way, you're going to get the same answer, okay? All right, let's move on to number 57 here very quickly. Number 57. Get a drink of water here. My throat is killing me. And here we go. Let's see what we have here. Negative 7 pi over 6. That's the same thing as negative 1 and 1/6 pi. So we're going to travel negative 1 whole pi and then a sixth more. So there we go. So the reference angle inside this little triangle here, or inside this little area right here, would be, we traveled 1 and then a sixth, so it'd be pi over 6, or 1/6 pi. And remember, the sign sequence here in quadrant 2 is positive, negative, negative. So you are more than welcome to use pi over 6 instead of negative 7 pi over 6, as long as you keep in mind your sign changes, okay? And so here we go. The sign of negative 7 pi, the sign of negative 7 pi over 6 would be the same thing as the sign of pi over 6, and so that would be pi over 6 1/2, and it is positive in this quadrant. The cosine of negative 7 pi over 6 is the same thing as this cosine of pi over 6, as long as you remember cosine is negative, and that would be square root of 3 over 2. And then the tangent of negative 7 pi over 6 is the same thing as the tangent of pi over 6, as long as you remember the tangent's negative. And so the tangent of pi over 6 would be square root of 3 over 3. Okay? Moving on to number 59. Number 59, if I can get this to work properly, there we go. And 11 pi over 4. Now, students, think about that. If you want to change it to degrees, you can. I'm just going to say this to you. It would be 2 and 3/4 pi, because 2 and 3/4 is the same thing as 11 over 4. So really, it's not that hard. Just look at it like this. Let's get this out of the way here. We're going to bring it down here. Now, I mean, think about this, students. We're going 2 and 3/4 pi. So here's 2 pi, and then here's another half a pi, and then a fourth. That's 2 and 3/4. So there we go. So if we went around 2 and then a half and then a fourth, inside here we're left over with pi over 4 for our reference angle right here. So instead of taking the cosine or the sine of 2 and 3/4 pi, you can use pi over 4 as long as you remember the sign sequence is positive, negative, negative. So the sine of 11 pi over 4 is the same thing as the sine of pi over 4, which is square root of 2 over 2, and it would be positive because of this. The cosine of 11 pi over 4 is the same thing as the cosine of pi over 4, as long as you remember it's negative. And let's see, we would get square root of 2 over 2, so negative square root of 2 over 2. And then the tangent of 11 pi over 4 is the same thing as the tangent of pi over 4, as long as you remember that tangent's negative. And so the tangent of pi over 4 would be 1, so negative 1. Okay? Oh, only one more left, and we'll be done with this section. This is a pretty long section here. And let's see, negative 17 pi over 6. That would be the same thing as negative 2 and 5/6, I believe. That should be correct. So let's see here. Negative 17 over 6 is negative 2 and 5/6. So we're going to rotate negative 2. And now be careful, 5/6 pi, okay? Now, that's definitely going to be, hold on one second here. 5/6, that's definitely going to be more than a half. Okay, so we're going to go like this. So we rotate 2, and then we rotate a half a pi. Okay, and then this is going to be not quite to 3/4. Okay, and sorry students, that's not correct. Sorry about that. 5/6, we'd rotate a half, and then another fourth, and then over to here, right here. So let's go over this again. We rotated 2 pi like this, and then 5/6 more, which I'm just estimating right around here. And so if you stop right here, the reference angle is going to be right here, right in here. And so if you went 2 and then 5/6, what you're left over with is 1/6 pi, or pi over 6. Okay, so instead of using negative 2 pi, 2 and 5/6 pi, or negative 17 pi over 6, you can use pi over 6 if you want to. So here we go. Let's see what we have here. The sine of negative 17 pi over 6 would be the same thing as the sine of pi over 6, as long as you remember all of your signs over here are positive. So the sine of pi over 6 would be 1/2. The cosine of negative 17 pi over 6 would be the same thing as the cosine of pi over 6, as long as you remember that you're positive, and that would be square root of 3 over 2. And then tangent of negative 17 pi over 6 would be the same thing as the tangent of pi over 6, as long as you remember it's positive. And so the tangent of pi over 6 would be square root of 3 over 3. And there we go. This is a great section. This has been really good practice for you guys, okay? Very good practice. Okay, here we go. Moving on now to number 63. The directions say for 63, 65, and 67 to find the given trig value in the specified quadrant. So, first of all, we know we're going to be in quadrant 4 because of this right here. So we're down here in this quadrant, put a check mark, and so we're going to draw our triangle like always. Remember the bow tie, okay? Remember the bow tie. So the triangle will look like this, and we'll put theta right here, okay? Now, sine of theta is 3/5 opposite over hypotenuse, so opposite over hypotenuse. If you use Pythagorean's theorem, this will be a 4. And what is the sine sequence down here? It's negative, positive, negative. So now they want us to find the cosine of theta. So the cosine of theta equals, well, cosine in this quadrant is positive, so we know it's positive. And the cosine would be adjacent over hypotenuse, which would be 4/5. That's pretty simple, okay? Number 65. We know we're in quadrant 3, so put a check mark here. Here's our triangle. We know theta is going to go right here. Okay. And what else do we know? We know tangent of theta is opposite over adjacent. So opposite is 3, adjacent is 2. And we know the sine sequence for this quadrant is negative, negative, positive. And the hypotenuse would be square root of 13. I believe I did that in my head. I think that's right. 9 plus 4, yes, square root of 13. So now they want us to find the secant of theta. Now think about this, guys. The reciprocal of secant is cosine, and cosine is adjacent over hypotenuse. So secant is going to be hypotenuse over adjacent. And also, if cosine is negative in this quadrant, the secant is negative also. So we know secant of theta is going to be negative, and it's going to be hypotenuse over adjacent, so it's going to be square root of 13 over 2. And there we go. Moving on to 67. All right. Now, they tell us we're in quadrant 1, so that's pretty simple. And so I'm going to go ahead and draw my triangle. Theta's here. Cosine would be adjacent over hypotenuse. So very quickly, grabbing my handy dandy calculator, 64 minus 25 would be 39. So I'm getting square root of 39. I hope that's correct. So here we go. I'm in quadrant 1, cosine of theta is 5/8, adjacent over hypotenuse. They want me to find the secant of theta. And so the secant of theta, are you serious? Boy, I wasted a lot of time on this, didn't I, students? If this is cosine, secant is the reciprocal, and you know if you're in quadrant 1, all the signs are going to be positive. So if the cosine of theta is 5/8, then the secant of theta is going to be 8/5. But I'll still go ahead and finish it for you. Cosine is adjacent over hypotenuse, and so secant would be hypotenuse over adjacent, which would be 8/5. Positive 8/5. We know it's positive because we're in the first quadrant, and everything is positive over here. Okay. Moving on to number 69, and it says use a calculator to evaluate the trigonometric function to 4 decimal places. So wow, this should be pretty nice. Make sure you're in degrees for this problem, and we'll go very quickly through these. The sine of 10 degrees would be point, it says round to 4 decimal places, so 0.1736. All right, moving on to 71, cosine, and then type in -110. Cosine of -110 would be -0.3420, -0.3420, 73. Now make sure you go to mode and switch over to radians. Okay, students, now we're in radians. And so now I'm going to type in my calculator tangent of 4.5, and I will get this out for my answer, 4.6373. Okay, moving on to 75. Tangent of 5 pi over 9, so make sure you're in radians, tangent of 5, and then hit your pi button, then divide it by 9, then close your parentheses. Tangent of 5 pi over 9 is -5.6713 because it's 2, 8, and so that 8 tells you to round that 2 to a 3. Alright, so there's your answer, number 77. Make sure you're in radians still, sine of -0.65, and you will get -0.6052 because we have a 1 and an 8, and the 8 tells you to round the 1 to a 2, and so there's your answer. Okay, moving on to number 79, and here we go. Find two exact solutions of each equation, and they want us to give our answer in degrees and in radians. So we're going to do this, and we're going to do this to get this up here, and here we go. Sine of 1/2. Now students, think about this. They want two answers, okay? So be really careful here. Now here we go. Watch this carefully. Sine of 1/2. They want to know, now listen students, they want to know an angle that when you take the sine of that angle, you get out a positive 1/2. Well, where is sine positive? It's positive here, and it's positive here. Got it? So I'm going to put a triangle here, and a triangle here. Now, what angle goes inside my triangle, my reference angle? Well, let's look at our table here. What angle, when you take the sine of it, gives you 1/2? Right here, it's the sine of 30. Gives you 1/2. So, put a 30 here, and then put a 30 here. So here are your two answers. Are you ready? Here's your two answers. Always start here and stop at the hypotenuse. So we're going to start here and rotate up. One answer is 30 degrees. Now for the other answer, we start here and we rotate here and we stop at the hypotenuse, and so we stopped 30 degrees short of 180, and so the other answer is 150. Now if you want to convert those over to radians, which you're supposed to do, you would get pi over 6. 30 degrees is pi over 6, and you would get 5 pi over 6 also, if you converted 150 to radians. Okay, moving on to number 81. Okay, they want us to find theta. When we take the cosecant of theta, we get a positive 2 over square root of 3. 2 square root of 3 over 3. Now cosecant is the reciprocal of sine, so once again, where is sine positive? Well, sine is positive here, and sine is positive here. So there's your two quadrants that we're dealing with. So we're going to put a triangle here, put a triangle here, And then what angle goes inside this triangle? Let's see. What angle when you take the cosecant? Here's cosecant. When you take the cosecant of theta, you get 2 square root of 3 over 3 right here. So it's 60 degrees. So there we go. So I'm going to go ahead and put a 60 here and a 60 here. And here we go. Start here and rotate to the hypotenuse. You get 60. Then start here and rotate to the hypotenuse. You stop 60 degrees short of 180. That'd be 120 degrees. Okay? Now, if you convert those over to radians, 60, of course, is pi over 3. And this should be 2 pi. If you convert 120 degrees over to radians, you'll get 2 pi over 3 radians. Okay? Moving on to number 83. Okay, students, let's take a look at number 83 here. All right, we're looking to find an angle so that when you take the tangent of that angle, you get 1. And so, where is tangent positive? Tangent is positive here, and tangent is positive here. So, we're going to draw a triangle here, we're going to draw a triangle here. We'll put, let's see, tangent is right here, so tangent of 45 gives me 1, and so we'll put a 45 here and a 45 here. Then remember, students, you always start here and stop at the hypotenuse, so we stop at the hypotenuse, that's 45 degrees, and then we start here and we go all the way to the hypotenuse. That'd be 180 plus 45 more would be 225 degrees. Okay, so if you converted 45 and 225 degrees over to radians, you would get pi over 4 and 5 pi over 4. All right, and moving on to number 85. Okay, it looks like here it says use a calculator to approximate two values of theta in degrees between 0 and 360 that satisfy the equation. So round the value to 2 decimal places. Okay, here we go. So first of all, we need to realize that we're dealing with this. Please watch carefully, students. That's a really good straight line. There we go. Now watch this carefully, students, if you would please. Sine of theta gives me out a positive number. Okay, so sine is positive here and here. Now with my calculator, make sure you're in degrees because the directions said it wants your answer in degrees. So make sure you're in degrees, students. And here we go. I'm going to hit second sine of 0.8191 and hit enter. And I'm going to get 54.99 degrees. So I'm going to put 55. So right here I put 55 degrees. And then right here I put 55 degrees. Okay? And then remember, you always stop at the hypotenuse. So I'm going to start here and rotate up, and I get 55 degrees. I'm going to start here and rotate to the hypotenuse, and so I'm going to get 180 minus 55 degrees would be 125 because you're stopping 55 degrees short of 180. So you would get 125 degrees. Okay, 125 degrees. And I guess it said to round to 2 decimal places in the directions. I did not see that, but I'm not going to worry about that. We're just going to go ahead and round to the nearest degree here. So that's good enough. Okay. All right. Moving on to the next problem. Number 87. Cosine of theta gives you a negative answer. A negative. So where's cosine negative? Cosine is negative. Cosine is negative here in this quadrant, and cosine is negative in this quadrant. So I'm going to type into my calculator second cosine of 0.4367. 0.4367. Hit enter. Oh, let me say this, students, by the way, when you type this into your calculator, I personally would not use the negative sign here because all that you're trying to do is you're trying to find the angle that goes inside the triangle. So please do not use the negative sign. I would not do that if I were you, okay? If you hit enter, you're going to get 64.10 degrees. So I'm going to put a 64 here, and I'm going to put a 64 here. And then remember, you always start here and stop at the hypotenuse to get your answers. So 180 minus 64 would be 116 degrees, so there's one answer. Then I start here, I go 180 plus 64 more, I stop at the hypotenuse, and 180 plus 64 is 244 degrees. So there would be your two answers, okay? All right, let's take a look now at number 89. And tangent of theta equals 2.521. So where is tangent positive? Tangent is positive here, and tangent is positive down here. So now with my calculator, I'm going to go ahead and hit second tangent, and then I'm going to type in 2.521, hit enter. I get 68.36 degrees. So I'm going to put a 68 here, and I'm going to put a 68 here. And then remember, to get your answer, students, you always start here on the positive x-axis and rotate to the hypotenuse. So we rotate here, that's 68 degrees. And then we start here and we rotate 180 plus 68 more. And 180 plus 68 is 248 degrees. So the other answer would be 248 degrees. Okay, let's take a look now at number 91. Number 91, and let's see, secant of theta equals negative. So let's see, secant is the reciprocal of cosine, and cosine is negative. Well, that's a really good line. Cosine is negative here, and cosine is negative here. So we're dealing with quadrant 2 and quadrant 3. Now, students, please listen to me carefully. Don't use the negative sign. All that we're trying to find out right now are the angles that go right here and right here inside the triangle. So if I want to know this, secant of some angle gives me 4.156. Do you remember what to do? There's no secant button on your calculator. So we're going to use cosine, which is the reciprocal of secant. But you have to flip 4.156, so it's 1 over 4.156. So I'm going to type into my calculator second cosine, and then 1 divided by 4.156. Okay, and then hit enter, and you're going to get 76 degrees approximately. So 76 goes here, and 76 goes here. So my answers would be, rotate here, we're not quite at 180, we're 76 degrees short, so 180 minus 76 would be 104 degrees. And then we rotate 180 plus 76 more, and 180 plus 76 is 256 degrees. Okay? All right, we're doing pretty well. One more of these, we'll move on to our last section. Okay, so we've done pretty well today. All right. Cotangent of theta equals a positive 15 point something. So where is cotangent positive? Well, cotangent will be positive where tangent is positive, and so tangent is positive here, and tangent is positive here. Now, there's no cotangent button on our calculator, so instead of using cotangent, we're going to type in tangent of theta equals 1 over 15.254. So here we go. I'm going to hit second tangent, and then 1 divided by 15.254, hit enter, and I'm getting something really weird. I'm getting 3.75 degrees. So I'm going to put 4 degrees here. Hopefully that's right, and put 4 degrees here. Okay, so rotate here to here, and theta equals 4 degrees, and then rotate from here all the way to hypotenuse. So 180 plus 4 more degrees is 184 degrees. I'm going to check that. I'm going to quickly take, theoretically, well, actually the answer is, no, those aren't the answers, but actually, if I take the cotangent of these answers right here, 4 and 184, I should get 15.254. So let's see. I'm going to take the tangent of 4 degrees, hit enter, and then flip it. And I'm getting, yes, very close to 15.25. So yes, we're good. And then tangent of 184, enter, and then flip that, and I'm getting the same thing, very close to 15. So we're right, so that's good. Okay, moving on to the last three. Now here, students, please notice we have no degree symbol here, no degree symbol here, and no degree symbol here, okay? And so we're dealing with radians. So right off the bat, let's go ahead and put our calculators in radians. I'm doing that right now, and you can do the same thing, okay? Now, here we go. We want to find theta so that when we take the cosine of theta, we get a positive 0.9848. Well, let's see. Cosine is positive here, and cosine is positive here, okay? So, next, I'm going to hit with my calculator second, make sure you're in radians, students, second cosine of 0.9848, hit enter, and I get 0.17 radians. So I'm going to put 0.17 here, and I'll put 0.17 here. Okay, students, I'm back here, so theta equals, when we start here and we rotate to the hypotenuse, that would be 0.17. Then we start here and we rotate all the way around, and students, look, we're 0.17 short. Now we're dealing with radians, okay? Remember, if you make a full rotation, that's what? 6.28 or 2 pi. So we're 0.17 short of going to 6.28. So I'm going to take 6.28 minus 0.17. And if you do that correctly, you will get 6.11. Okay? All right. Moving on to number 97. All right. Tangent of theta equals a positive. Well, let's see. Tangent is positive here and here. Now, I'm going to hit second tangent on my calculator, make sure I'm in radians, and then 1.192, enter, and I'm getting 0.87. So right here, I'm going to put 0.87, and right here, 0.87, okay? And now we're going to rotate from here to here, so one answer is 0.87, okay? And then remember, students, if you rotate from here to here, that's pi or 3.14, and then you rotated 0.87 more, so you really have 3.14 plus 0.87, and you will get 4.01. 4.01. Okay? All right. And then last problem, number 99, finally. Secant of theta gives you a negative number. So secant is the reciprocal of cosine. And let's see, cosine is negative here, and cosine is negative here. There we go. Now, there's no secant button on my calculator, so I'm going to type in cosine and use 1 over 2.6667. Students, remember, don't use the negative sign. It's not important. Okay, right now, we're just trying to find this angle inside the triangle. Okay, so cosine, second cosine of 1 divided by 2.6667. Make sure your calculator's in radians. Hit enter. I'm getting 1.18. So here I'm going to put 1.18, and here 1.18. Now, students, think about this. I'm going to start here and rotate to the hypotenuse. If I would have gone all the way to here, that would have been 3.14, okay? But I did not. I stopped 1.18 short. So I'm going to type in 3.14 minus 1.18, and I'm going to get 1.96. So theta equals 1.96. Then students, think about it. I'm going to rotate from here to here. That's 3.14 plus 1.18 more. So I'm going to take 3.14 plus 1.18, and I'm going to get 4.32. And there we go. There's the two answers to theta. Okay, while it's a super long video, my voice is really shot. I hope this has helped you. If you have any questions, don't hesitate to call or email.